Welcome to Behavioral Patterns. In this video, we are looking at chain of responsibility, a pattern that lets you send a request through a sequence of handlers, where each handler decides whether to process it or pass it along to the next one. You will find this pattern powering middleware pipelines, authentication layers, and browser event bubbling. Imagine building an HTTP server. Incoming requests might need authentication checks, then logging, then rate limiting, and finally routing to a controller. If you write all of that logic as one big block of if-else statements, every new requirement means editing that block, and the code that fires the request is now tightly coupled to every possible handler that might act on it. That coupling is the pain this pattern is designed to remove. Think about calling a tech support hotline. You reach a first-year agent who handles common problems. If your issue is beyond their authority, they transfer you to a second-tier specialist who can transfer you again to an engineer. You, the caller, never decide who handles the ticket. You just describe your problem, and the chain takes care of the rest. That is exactly the relationship between a request and a chain of handlers. The gang of four intent is, avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle it. There are three participants to learn. First, the handler, an interface declaring a method to handle a request and optionally to set the next handler. Second, concrete handlers classes that implement the interface, each one either handles the request or forwards it. Third, the client, the code that assembles the chain and triggers it by calling the first handler. Let us walk through this. The handler interface declares two methods: setNext, which links the next handler in the chain, and handle, which processes a request. Abstract handler implements both. It stores the next handler as a private field, and its default handle implementation simply delegates to that next handler, if one exists, returning null when the chain is exhausted. Low handler overwrites handle. If the number is less than 10, it acts on it. Otherwise, it calls super.handle to pass the request forward. Mid handler does the same for numbers under 100. High handler always acts, making it the final catch-all. Down in the client, we create a low handler and call setNext, which returns the mid handler we just set, so we can immediately call setNext again on it. That fluent style builds the full chain in one expression. Sending 5 goes to low handler and stops. Sending 42 passes through low handler and is caught by mid handler. Sending 999 travels all the way to high handler. At runtime, the client sends the request to the first handler and then steps back completely. Each handler inspects the request and either handles it and returns a result, or calls the next handler and returns whatever that call produces. Because the chain is just a linked list of objects, you can add, remove, or reorder handlers without touching the sender at all. That is the decoupling payoff. The trade-off to watch for is that requests are not guaranteed to be handled. If no handler in the chain matches, the request silently falls off the end, so you need a catch-all or explicit logging at the tail. Reach for chain of responsibility when you genuinely have a variable or growing set of handlers that should each get a shot at a request, and when the sender should not care which one acts. Middleware stacks are the textbook example. Skip it when the logic is simple enough that a switch statement or a strategy map communicates intent more directly. Also be cautious when a response is required. An incomplete chain returns nothing, and tracking down where a request silently disappeared in a long chain can be frustrating to debug. To recap, chain of responsibility connects a series of handler objects, so a request travels the chain until one of them acts on it. The sender never knows which handler will respond, which keeps it fully decoupled from the processing logic. Because the chain is assembled at runtime, you can extend behavior without modifying existing handlers. Just remember the key gotcha: if no handler matches, the request disappears quietly, so always think about what should happen at the end of the chain.